Hello, and congratulations on your admission to the UCLA Statistics program. Obviously, this year with the pandemic, we're unable to meet you all in person, but we hope that these videos can help give you a better idea of who we are as the faculty and what's going on across the Department of Statistics. My name is Karen McKinnon. On the lower right-hand corner, you can see my research website, which I encourage you to check out for more information. My research group actually sits half in statistics and half in the Institute of the Environment and Sustainability. And my research is focused on better understanding climate variability and climate change using novel statistical and data science methods. A little bit about my background. I got my PhD in Earth and Planetary Sciences at Harvard in 2015. I then pursued a postdoc at the National Center for Atmospheric Research for 2 years between 2015 and 2017. I worked in the private sector for a year at a small startup called Descartes Labs, where as an applied scientist, I used machine learning and other methods to analyze and build models for large-scale satellite data. And I've been here at UCLA since late in 2018, again as a joint assistant professor between the Statistics Department and the Institute of the Environment and Sustainability. A brief overview of my research interests, a small selection. One is extremes, various climate extremes. Here are just 3 papers that cover that topic. The one on the left-hand side about doing skillful subseasonal predictions of heat extremes in the US East Coast. And the right-hand side here, we were looking at describing how the distribution of Northern Hemisphere summer temperatures were changing with an implication for the probability of extremes. And here on the lower left-hand side is some recent work on trying to estimate changes in the relationship between humidity and temperature, with a particular interest in better understanding how humidity extremes were changing when temperature extremes were also high. And this is focused on kind of the emerging field of compound extremes within climate science. Another topic of interest of mine is internal climate variability. And you can think about this as basically the noise in the climate system that is present in both our observations and climate model simulations. And we're interested in exploring this noise to really better understand how we can interpret our observational record and make robust predictions for the future. And so in this first paper on the upper left, we were developing statistical methods to model that noise. On the right hand side is a larger perspective piece working with a team focused on large ensembles to demonstrate kind of where we are in the field with these ensembles and future prospects. And I'm sorry, I should say large ensembles are a tool within climate science to essentially model this climate noise or focus on understanding this climate noise in the context of climate model simulations. And on this lower left-hand side is a recent paper focused on how we can use our knowledge of this climate noise to do robust decision-making for the future. And the final set of research I'll feature today are just generally statistical methods for climate data. So these are 2 papers led by students, one led by Maxime, who's actually at Harvard where I did my PhD. And this was focused on using Gaussian process models to do bias correction for temperature measurements, essentially back out true temperature measurements from the ones that we have, knowing an error process that led to the ones that we have. And on the lower right-hand side is some of Sam Baugh's PhD work, trying to infer ocean heat content from a limited set of in situ measurements that are shown here in all of these dots in this map. My current group is Sam, whose research I talked about on the previous slide. He's currently a 4th-year statistics PhD doing flexible Gaussian process modeling focused on ocean data. Russell Horowitz is finishing up his master's in the Institute of the Environment and Sustainability, and in conjunction with Wenwen Kong, a recent postdoc, he's working on atmospheric and land surface controls on temperature extremes. We also run a Climate and Statistics Journal Club that involves both my group members as well as students and faculty across the university interested at the junction of these 2 fields. And I'll end just with a quick slide on why doing statistics on climate data is both fun and important. So if you're a statistician, you might think I'm not really a climate scientist, why would I want to jump into this? But I think there's 2 major reasons. One is that climate data is really interesting and has lots of unique challenges that actually motivate advances in statistical methods. And the second is that right now we just have a lot of important and societally relevant questions about climate change that you could help answer with your statistical skills. And it gives you an opportunity to really learn about the climate system. So please get in touch with me if you're interested in any of these topics, research, the journal club, etc. And I hope that I'll see you at UCLA next year.